Hi, my name is Elisha Mugenyi and I'm here to talk about the interview questions that have been given. The first one is to describe how you would write a function to find the intersection of two sets. First of all, I would compare two sets, let's say example set 1 is set A and set B. And what I'll do, my approach is I'm going to use a for loop to iterate through all elements in set A and then compare each element from set A to set B. And if I find a common element, I would add it in the intersection set, which set I would have created as an empty set to hold my common elements. And with that done, when I complete iterating through each element, I'm going to return the intersection set. And that is my step-by-step discussion. And so the big O performance is literally on average checking an element is 1. But since I'm checking each element from set A, and my set A element number of elements could be n, a specific number of elements that I don't know, I'll call it n. So my big O notation is going to be an On, depending on the number of elements in set A, and compare them to each element in set B. Comparison takes 0, 1. And so my big O performance is going to be O n. And the three test cases that I would try would be 1, I'll check the basic overlaps, just get two sets with numbers maybe overlapping, and then I'll test them. The second test will be using identical sets. I'll get sets with the identical elements and then I'll check it. And the third test would be checking for one set which has elements and another has 0 elements, so it's empty. And I also check that to find out. So those will be my test cases. And for question 2, it asks how would you write a function to find the union of sets of two sets. And the approach I'll take for this will be I'll have two sets, and then I'll also have an empty set which I'll call my union. The union is going to hold all elements from set A and set B, for example. And I'll use a for loop to iterate through elements in set A. So for elements in set A, I would add each element in the union set. And then I would iterate through set B for all elements in set B. You check them and you add them. However, I'll add an if statement so that I do not have duplicates. Now for each element I go through in set B, I'll compare it to all elements which are already existing in my union set. And so if I find an element which exists or which looks alike, then I'll omit that one and I'll move on to the next one. So my for loop is going to help me go through set B, and the if statement is going to help me catch the duplicates. And once it's done, the function is going to return the union set with all elements from set A and set B. And the big O performance is also going to be, or let's say n, depending on the number of elements in set A, and m, depending on the number of elements in set B. Let's say there's m number of elements in set B. And therefore my big O performance is going to be O brackets n plus m. N plus m, because I'm depending on n number of elements in set A and m number of elements in set B. And that is going to be my performance. And the test cases are going to be basic overlap, identical sets, and empty set.